This is the first of 3 lessons on the angle between vectors and something we call the scalar product, kind of multiplying 2 vectors together. Here we've got an angle between 2 vectors. So we've got the vector A, the vector B, and we'll call the angle theta. We can see that the 2 vectors are directed in the same direction away from the angle. In this example here, they're directed in different ways, and here the angle between the vectors wouldn't be defined as this acute angle here, but if we continue one of the lines like so, we now have this obtuse angle where the vectors are pointing away from the vector. It also works if both angles are pointing towards the vector, but they must be pointing in the same direction. The vectors must be directed the same way, either into the angle or away from it. So we call the angle theta. We write the scalar product like this, with this dot in the middle, and that's important, and we define it as the product of the magnitudes and the cosine of the angle. The result is a scalar, it's a number, it's an amount. And we often refer to it as the dot product for short. So as I said, we've got the magnitudes. We've got A times B, which is the product of the magnitudes of the vectors. If we've got, as we've got here, an angle and 2 vectors 8 and 10, and then here we've got the same angle but vectors of different sizes. Here we've got 6 and 10. We get a different scalar value, a different value for this scalar product. You can see here we get 69 for the first one and 52 for the second one. In other words, different size vectors at the same angle produce a different scalar product. The same is true if we have the same size vectors and different angles. And we'll use an example here where we've got 150 and 30, which add up to 180, which produces an interesting result. There we are. Try experimenting with some other angles which add up to 180 yourselves. So we can use this dot product to find the angle between vectors, even when it's in 3 dimensions. If the dot product equals 0, if magnitudes multiplied together times the cosine of the angle between the vectors equals 0, that means that one of these factors has to be 0, either A, B or cos theta. It doesn't really make sense for A or B to be 0. That means the vectors don't exist. If they exist, they must have some magnitude. So that implies that cos theta must be 0. And if cos theta is 0, then theta is 90 degrees. In other words, the vectors are perpendicular to each other. So to summarise, the scalar product we write like that, and we define it as the 2 vectors multiplied together equals the product of the magnitudes of the vector and the cosine of the angle between them. Remembering that the angle between them is always where the vectors are directed either both away or both in the direction of the angle, and not with them in different directions. If the dot product equals 0, because A and B can't really be 0, then that implies that the cosine of the angle between the vectors is 0, which means that theta, the angle between them, must be 90 degrees. In other words, the vectors are perpendicular. Right, have a go at these. The 3 in question 1 I would now expect you to be able to do. I'm not quite so bothered about 2 and 3. Now, I don't need a bit of thinking about. It'd be lovely if you can work out, if you can logic it out for yourselves. But if not, just have a look at the answers and then try and make sure you understand why. But as I said before, make sure you can do A, B and C on number 1. Okay, so solutions, 12 for A, you get 0 for B because it's a right angle, and remembering that on that one, because they're directed in a different way, that you have to take the other angle, the 180 minus 120, which is 60 degrees, and you get an answer of 8. Right, these are just the same vector, so it just required a little bit of thought really. The angle between a vector and itself is obviously going to be 0. So if the angle's 0, we get cos 0, which is 1. So we get the product between the two angles will be magnitudes times 1, which gives you a squared. Remember that I, k, along with j, which doesn't feature here, are unit vectors with a magnitude of 1. So I times I has to equal 1. So I times k will equal 0 because theta would be 90 degrees. And again, think about it, think how those unit vectors work. Remember what we did in previous lessons. Think about how they go along the axes and what the angles between them must be. I'll talk a bit more about 2 and 3 in the lesson. This next bit, I'm just going to show you how it's done. We haven't done the matrix algebra it's not covered in the single maths A level. So I don't really want to go into all the results you'd get if you multiplied out the vectors and why only 3 of them are relevant. But if anyone's interested, I'm quite happy to do so. But for the purposes of what you need to know, to find the product of 2 vectors when you're given the vectors, so we're now working out the left-hand side of our equation, we multiply out the tops, we multiply out the middles, we multiply out the bottoms, and we add the results. So if we're working out the left-hand side of that scalar product equation, the A dot B, the dot product part, this is how we do it. So for example, we're working out the scalar product and we're given the 2 column vectors, we can simply do it in that way. Multiply the tops, 2 times 4, plus multiply out the middles, plus multiply out the bottoms. Here we've got to show that they're perpendicular. So if we do that process, what result do we expect? Think back to what we've just done a bit earlier. Multiply them out, you should get a result of 0. So to prove that 2 vectors are perpendicular, you can multiply them, you can find the dot product, and if it equals 0, they must be perpendicular. Okay. Right, to finish off then, have a quick go at this question here. Should be able to do all of this really. If not, perhaps you need to go back over it. So we multiply out We do get 0 in part B, so that tells us that the vectors are perpendicular.